Section 5.3, more on factoring trinomials. Last time we had looked at trinomials of the form x squared plus bx plus c. In other words, the leading coefficient on your square term was 1. Now we're going to look at trinomials where that leading coefficient is not 1. Ax squared plus bx plus c, where a is not 1. Now I'm going to start with objective 2. I'm going to take the section backwards from the way she presents it. There are two methods in this section. The one we're going to look at today, she calls the FOIL method. I call it unfoil, because we're tearing apart a trinomial. And here's how it works. We're going to go ahead and grab a homework problem. Number 24. Now, this unfoil method is also called trial and error because there is some guessing. There's not nearly as much guesswork as one would initially think. There are a lot of things that we can lock down as we go. And we've got to think about, where did this trinomial come from? If it factors, it will factor as a pair of binomials. We're going to unfoil this. Where did this first term come from? Well, that came from the f in FOIL. That's the product of the first. What would give me a 7r squared? Well, it's got to be a couple of r terms. And the only way 7 can fall apart is 7 times 1. I'm not going to write the 1 as a coefficient on r. So far, I haven't guessed at anything. My signs in the trinomial still tell me the same things. This sign tells me that the signs in my binomials will be the same. And this sign tells me, in fact, in this problem, they will both be plus. I still haven't guessed at anything. Where does this final numeric term come from? It comes from the product of the last, the L in FOIL. It comes from multiplying the last. And the only way a 1 falls apart is 1 times 1. I haven't guessed at anything. Now the question is this the way that trinomial factors? And the way we find out is we check the outside and the inside. Check the outside. 7r times 1 is 7r. 1 times r is r. Add them up. Do they total, because you would add the outside and inside as like terms when you FOIL this back together, do they total 8r right there in the middle? Yes, and so this is how it factors. Now it turns out there was no other way to do the 7 but 7 and 1. There was no other way to do the 1 but 1 times 1. There was no other way to do the signs but the same, both positive. And so if this had not checked, there were no other guesses we could make, and this would have been prime. We'll get a better feel for this the more of these that we do. Let's try number 26. We're unfoiling. This is trial and error, but there's not as much trial and error as you might expect. There are a lot of things that we already know about the answer that we can go ahead and lock into place. The instructions simply read factor, and we know that that means factor completely. We should be checking for a greatest common factor as we go. That's the first step of any factoring problem. There's no greatest common factor here other than 1 for me to factor out, so we're ready to go ahead and try to unfoil this. If this trinomial factors, it will factor as a pair of binomials, each starting with some z term. And in fact, I can lock that down further. 5 is prime, so the only way a 5 falls apart is 5 and 1. I don't write the 1. 5z times z, when I FOIL this back together, will give me that 5z squared. Now let's look at this last term and our signs. First of all, our signs. This sign says that the two signs in my answer will be the same. In fact, this sign says, once again, they'll both be plus. Now we do have a little guesswork here. Because how does this 4 fall apart as the last, the L in FOIL? 4 could be 1 times 4. It could be 4 times 1. It could be 2 times 2. The more of these you do, the more your gut will tell you which direction to head. I'm going to do this in a particular way, simply for the sake of our notes. I'm going to start with, well, let me try 1 and 4. Now, if it factors this way, my outside and inside should add up to that 12z as we FOIL this back together. The outside gives me plus 20z. The inside gives me plus z. A total of 21z. That's not it. So it's not 1 and 4. Well, then maybe it's 4 over here and 1 over there. Maybe that's how I get the 4. Let's check the outside and inside. The outside, plus 5z. The inside, a plus 4z. Totals 9z. I'm looking for 12z there in the middle. So that's not it. The only thing we haven't tried for this 4 is a pair of 2's. Maybe it's 2 and 2, because 2 times 2 would give me 4. So let's check my outside and inside. The outside gives me 10z. The inside plus 2z, a total of 12z. And so that's how it factors. And of course, we've checked this as we went along. We've already FOILed this back out, haven't we? The first, right there, gives me the 5z squared. The last was by design, so I'd get a 4 at the end. And then my outside and my inside will combine as like terms to give me that 12z. And so this is factored. So a little bit of guessing there, because this 4 could have been what? A 1 and a 4, or a 4 and a 1. Could have been a 2 and a 2. Those are the only factor pairs of 4. If we'd gone through them all and found nothing that gave me that 12z back in the middle, then I would know that this is prime. Let's have a look at number 30. I don't always mention it, but it always goes through my head. To me, it has become so automatic that sometimes I forget to mention. Look for a greatest common factor. That should become automatic to you. When you do a factoring problem, look to see if there's some greatest common factor that needs to be factored out. In this problem, no. Greatest common factor is 1. There's nothing I can factor out other than that common factor of 1. So, if this factors, if this will unfoil, it will fall apart as a pair of binomials, each starting with some x term. That's how I'm going to get an x squared back. And I'm going to have to guess at what goes with the x's this time, because 20 could be what? 20 could be 1 and 20. It could be 2 and 10. It could be 4 and 5. Those are the factor pairs for 20. Let's write down what else we actually know. Right here, this tells me my signs will be opposite. A negative here on my numeric term tells me one of these will be plus, one will be minus. This sign doesn't tell me quite as much in this kind of problem as it did last time. So let me come back to that idea here in a minute, and I'll show you what it actually means. What else do we know? Well, my last term is a 3, and there's only one way to factor a 3. It has to be a 1 and a 3. Now at this point I am guessing at which one goes with the plus and which one goes with the minus. But it's got to be 1 and 3 or 3 and 1. That's the only way a 3 can fall apart. So now we start guessing how that 20 is going to fall apart. Let's try the 4 and the 5. Let's try the 4 and the 5. 4x and 5x. So What do I know is correct so far? That if I multiply this out, I'll get the right first term, I'll get the right last term. But what's in question? Do the outside and inside give me that 11x back? Well, let's see. The outside, watch your signs, minus 12x. The inside, plus 5x. A total of negative 7x. That doesn't work. Well, then maybe the 4 and the 5 should be 5 and 4. Put the 5 over here and the 4 over there. Let's see what happens now. The outside gives me minus 15x. The inside gives me plus 4x. A total of negative 11x. Oh, so close. But guess what? It's close enough now to know the answer. Because this gave me the opposite of what I need, the only thing wrong with my factored form is where my signs are. All I have to do, if I get the opposite of what I need in the middle, is swap my signs. This should be the minus, that should be the plus. Because now look, the outside gives me plus 15x. The inside gives me minus 4x. A total of plus 11x. And so this is how that factors. If that had not happened, we would have gone on to try the 2 and the 10. If that didn't work, we'd go on to try the 1 and the 20. But we found it before we got even close to exhausting the possibilities. And like I said, the more of these you do, the more of a feel you will have for where to start guessing. Number 34. Check for greatest common factor. Nope. 9 is nothing but 3 times 3. 3 won't divide into 8. And so there's no common factor I can factor out other than 1. So if this factors, if it will unfoil, it will factor as a pair of binomials, each starting with some p term. What do I know about my signs? I know that they are the same, and in fact they are both minus. And now I've got some guessing to do. This 9 could be a 1 and a 9, or it could be a 3 and a 3. This 8 could be a 1 and an 8, or a 2 and a 4. Those are all the factor pairs of 9, all the factor pairs of 8. So, where do you want to start? I think I'll start with the 3's for my 9. When I break this 9 apart, I'm going to use 3 times 3. So 3p times 3p is what gives me back my 9p squared. Now, how should this 8 fall apart? I don't know. Why don't we try 2 and 4? Check the outside and the inside. The outside gives me minus 12p. The inside minus 6p. A total of, we hit it the first time, a total of negative 18p. That's how it factors. Now, let me point out something. If this had not worked, would there have been any point in trading the 2 and the 4 places? No, it would have been the same problem, wouldn't it? Because it's 3p minus and 3p minus. So swapping the 4 and the 2 would be the same as what I have here. If I'd been using the 1 and the 9, then yes, swap the 4 and the 2, because that will be something different. But we got lucky and hit this one the first time. Let's have a go at number 36. Check for a greatest common factor. Well, 11 is prime, and 11 is not a factor of either of the others, so no greatest common factor other than 1. If this factors, it will factor as a pair of binomials, each starting with some kind of x term. What else do I know? I know my signs will be opposite. Oh, I forgot to tell you what that thing meant. Let me tell you in this one then what that middle sign means when you've got opposite signs. Let's wait till we get to the end of the problem. Now, we've got a couple ways to approach this. This 10 could be a 1 and a 10, or it could be a 2 and a 5. This 6, we could try 1 and 6, or we could try 2 and 3. Usually, when this number in the middle is in the same range as these other two numbers, I will start with these factor pairs further toward the bottom of my list rather than 1 in the number itself. So I'm going to start with the 2 and the 5. Might be right, might not be. We'll find out. Let me use this problem to illustrate something. Is it possible that for my 6, it's 2 and 3 as I've written it here? Okay? We've got our first term, 2x times 5x is 10x squared. And now for my last term, as that 6 falls apart, could it be 2 and 3 the way I have it written here? No, I'm not even going to check. Why don't I need to check? Because look at this one factor by itself, 2x plus 2. 2x plus 2 has a greatest common factor of 2. The original problem didn't have a greatest common factor of 2, so we can't have a magical greatest common factor of 2 just show up in the middle of the problem. This would be impossible. You can check the outside and the inside if you want. I'm not going to because I know it couldn't possibly work. Likewise, there is no sense in checking a 6 here and a 1 there for my 6, because I have a greatest common factor of 2 once again. A magic greatest common factor which did not originally exist. So that cannot be it. Nice, there's 2 things I don't have to check. Now, I could put the 1 up front with the 2 and the 6 over here with the 5 and see what that does. That might work. Let's check the outside and the inside. The outside gives me minus 12x. Watch your signs. The inside plus 5x. A total of negative 7x. That's not what we're looking for in the middle. So let's see. Well, haven't we tried the 2 and the 3? But what? The 3 has to go with this 2x, so as not to create a magic greatest common factor that wasn't originally there. Now check the outside and the inside. The outside, minus 4x. The inside, plus 15x. A total of positive 11x. And so what do we know? We're close. The only thing wrong then is what? The signs. Swap these signs, make this the minus and that the plus. And then my outside is positive 4x, my inside is minus 15x, and that totals the correct negative 11x. Even though it's trial and error, and we have a lot of things to guess about, there are also a lot of things we don't have to guess about, because we know that they're locked in place. For example, we didn't have to try 2 here and a 3 there because of a magic greatest common factor that would appear. We didn't have to try 6 here with the 2x because a magic greatest common factor would appear that did not originally exist. All right, how about number 38? There's no greatest common factor to factor out. 2 is prime. 2 is not a factor of 15, so there's nothing to factor out as far as the greatest common factor. If this factors, it will factor as a pair of binomials, each starting with some t term. In fact, I can say more about this one. 2 is prime. The only factor pairs of 2 are 2 and 1. If it factors, that's guaranteed. I'm not guessing at anything. I'm not guessing. I still didn't show you what that sign meant on the last one, did I? Let me back up for just a minute to that last answer. In number 36, we had 10x squared minus 11x minus 6. The minus on the 6 told me we had opposite signs. And once we got this figured out, this was our answer. What this tells me, this middle sign, This minus tells me that they're opposite in sign, and last time when we were doing trinomials with leading coefficient 1, this sign told me the larger of the two numbers I'm looking for will be the negative one. Well, in these problems, it's not as helpful. What it means is that the larger of the inside and outside will end up being the negative one. And, we don't find out what those are until we actually check. So, when your signs are opposite, and we have a leading coefficient that's not 1, that sign is not that big a deal in these problems. In the previous problems, yes, it helps me find the two numbers I'm looking for. But in these problems, not so much. Okay, back to number 38. Everything we've written down so far is guaranteed. It will be a pair of binomials. It's got to be 2t and t because there's no other way 2t squared can fall apart. This tells me my signs will be the same, and in fact, right here, they will both be minus. And now we've got to figure out, is it 1 and 15? Is it 3 and 5? Those are the only factor pairs of 15. Let's try the 3 and the 5. Negative 3 times negative 5 gives me back that 15, right, as the L in FOIL. So now let me check the outside and inside and see that I get, if I get a negative 14t in the middle. The inside gives me minus 3t, the outside gives me minus 10t, a total of negative 13t. Nope, that's not it. All right, let's stick with the 3 and the 5, but swap places. Let's try the 5 over here and the 3 over there. Now the inside gives me minus 5t, the outside minus 6t, a total of negative 11t. Still not what we're after. So it's not the 3 and the 5. We've tried those both ways. How about 15 and 1? The inside gives me minus 15t, the outside minus 2t, a total of negative 17t. Well, it's not 15 here and 1 there. Maybe it's 1 here and 15 there. The inside gives me minus t, the outside gives me, oh no, this is definitely not it. Negative 30t, a total of negative 31. That's the furthest we've been off. What else is there to try? Well, there's nothing left to try. We've tried all factor pairs of 15. 2 only has the factor pair 1 and 2. So it's got to be 2t and t. No other way to do that. We've tried 3 and 5, 5 and 3. We've tried 15 and 1, 1 and 15. We're out of factor pairs. This won't factor. There's no arrangement that will give me that first and that last, and also give me the correct middle term from the outside and inside. So this guy's prime. Now, I'm not going to get too worked up about prime today. In our second look at this section, when I look at what she calls objective 1, I'm going to show you, instead of a trial and error method, I'm going to show you a guaranteed method. And that guaranteed method will be guaranteed to show us when a trinomial is prime. That is, if we've guessed our way and just can't get anywhere, and we think we've tried everything we can try but we're not sure, we can put it through that guaranteed method and see if it is really prime. So why aren't we just doing that method? Because this method is faster. This trial and error, this unfoil method, is faster, especially the more you practice it. Our guaranteed method, it's slower. It takes more time. It's going to waste more time. But if you get stuck, it is guaranteed to work every time. So there are occasions when you will want to use it, and I use it a lot in actually chapter 6, when we check our rational expressions for lowest terms. We'll worry about that in the next video. Let's continue our look at this trial and error method, this unfoil. Number 42. Now don't write this down. Don't write this down because I'm about to erase what I'm about to write. If this factors, it will factor as a pair of binomials, each starting with some b term. Signs are opposite. Everything I've written is guaranteed. This 10 could be a 1 and a 10 or a 2 and a 5. This 48 could be a 1 and a 48, a 2 and a 24, a 3 and a 16, a 4 and a 12. Not a 5, but how about 6 and 8? Not a 7, and we've already discovered the 8. That's a lot of trials, and there are problems where you will have to go up against something like this, but not this problem, because what did I forget to do right at the beginning? Always, always, always. First things first. You should have it big in your notes, highlighted. Always, always, always look for a greatest common factor first in any factoring problem. In this problem, all of these numbers, all of my coefficients are even. And so I can factor out at least a 2. Let me see. If I pull a 2 out of that 10, it leaves a 5. Nothing here is, other than the 10, is divisible by 5. So 2's got to be the biggest. 2's got to be the biggest. Factor out a 2, and that will leave me 24b squared minus 37b minus 5. Oh, I like those numbers better, right? Because 5 is prime, there's only one way it can fall apart. I'm just going to be guessing at this 24. So here in my next step, don't forget your greatest common factor. Don't lose him. If he disappears, you've lost points. And in factoring, I give very few partial credit points. If this problem is worth 3 points, you do everything right except you lose that 2. Out of 3 points, I'm only letting you keep 1. Because factoring is so critical. And it's such a tiny piece of much bigger problems, we've got to get it right every time. Now, if this trinomial factors further, if it doesn't, then there's my answer. But if it does, it will factor as a pair of binomials, each starting with some b term. That's how I get the b squared back. Signs are opposite. One's plus, one's minus. I know that for this 5, the only way a 5 can fall apart is 1 times 5. Nice. Now, I am guessing it. Does the 1 go with the positive or does the 1 go with the negative? But you know that will show itself when the time comes. If we get a positive 37b back in the middle, we know I just need to swap my signs to finish the problem. Now we start guessing at that 24. And that 24 could be 1 and 24. It could be 2 and 12. It could be 3 and 8. It could be 4 and 6. So, where do we start? What does your gut tell you about where to start? Well, that 37 is kind of in the neighborhood of that 24. It's not some wild, outlandish number compared to that 24. So, how about the 4 and the 6? The more of these you do, the faster you get at them. The more your gut is going to tell you what's a good place to start. Check the outside and the inside and see if we happen to get it the first time. The inside is plus 6b. The outside is minus 20b, a total of negative 14b. We're looking for negative 37. So it's not 4 and 6. Maybe it's 6 and 4. Maybe the 6 goes here and the 4 goes there. Well, that gives me 4b in the middle and minus 30b on the outside. That totals negative 26b. Still not what we're looking for. So it's not 4 and 6. Well, then I'm inclined to try the 3 and the 8. Let's try 3 and 8 and see what happens. The inside gives me plus 8b. The outside, minus 15b. A total of, no, definitely not. That's negative 7b. Nowhere close to what we're after. Well, let's swap these. Instead of 3 and 8, maybe it's 8 and 3. Check your inside and outside. The inside gives me plus 3b. The outside minus 40b, a total of, there we go, a total of negative 37b. So this is how it factors, with that greatest common factor of 2 sitting out front there. Let me give you one to try. Let me have you try number 58. And I will start by saying number 58 is not ready to go. Do the first step with me. Okay? What do you want to do with this before you actually start factoring? I'm not talking about greatest common factor. I'm saying this problem looks a little strange. What's the first thing you want to do? Let's write this in descending powers. We're accustomed to having our squared term up front. So let's go ahead and rearrange this. Put the 7x squared up front, then my 65x in the middle, 18 at the end. Okay. Check for greatest common factor. Let's see, 7 is prime. 7 won't go into 18. No greatest common factor other than 1. So you're ready to say, if this will factor, it will factor as a pair of binomials, each starting... Okay. Why don't you pause the video and try it from there, and then come back and we'll compare answers. If it factors, it will factor as a pair of binomials, each starting with some x term, but I can nail this one in place right now because 7 is prime. It has to be 7x and x. There's no other way for a 7 to fall apart. What else do I know for sure? I know my signs are the same. I know they're both plus. This 18 could be a 1 and an 18, a 2 and a 9, a 3 and a 6. That 65 is kind of wild compared to the other two numbers. I'm kind of tempted to start, maybe not with the 1 and the 18, but what about that 2 and 9? And now think about where you might put them. If I put the 9 here, think ahead. That's going to be a 9x and what, a 14x. That's nowhere close. But if I put the 9 here, what's the outside going to be? 63. I think we might have something. The inside is plus 2x. The outside is plus 63x. That gives me plus 65x back in the middle. And so that's how this one factors. How'd you do? Let's have a look at number 68. First things first. I mean, if I'm stuck with a 48 and a 9, so be it, I guess. But I hope there's some greatest common factor that will tune those numbers down just a little bit. Is it obvious to you that all of these are divisible by 3? It should be. You should know your rules of divisibility back from the homework assignment in chapter 1.5. And then again, when we came across that table showing our rules of divisibility, I think in section 5.1. It should be obvious these are all divisible by 3. The only thing else they could be divisible by that I would care about would be 9. Because 9 is 3 times 3. They all contain a 3. Do they all contain a couple of 3s? No, these other two are not divisible by 9. So 3 is the greatest common factor. Factor out of 3. Pull the 3 out of 48, it leaves us 16. T squared. Minus 3 goes into 147. What's that going to be? 49? 49 times. And 3 into 9 will go 3 times. I like that better. All right. Don't forget your greatest common factor. And if this trinomial factors further, This time, we've got an extra variable running around. This time, it will factor as a pair of binomials, each starting with some t term. My signs will be the same. In fact, they're both minus. And what? Each ending with some kind of s term. Now we've got to figure out how these things fall apart. There's only one way for this 3 to fall apart. It's got to be a 3 and a 1, 1 and a 3. It doesn't matter where you put what. 1 and 3. I'm not going to write the 1 as a coefficient on this s. Now, 49 is kind of big compared to the other two numbers in this problem. So I'm thinking with my 16, 1 and 16, 2 and 8, 4 and 4. I'm thinking, how about we start in the middle again with that 2 and that 8? How about a 2 here and an 8 there? My gut tells me this is already wrong. I think I want the bigger number to be on the outside with that 3. But let's go ahead. I've already written it. Let's check it. In the middle, that's a minus 8 TS. I would probably write ST, but it's TS in the problem. Same thing. The outside is minus 6 TS. A total of negative 14. Nowhere close. So maybe my gut was right. And if I put the 8 over here so that it pairs up on the outside with that 3, 8 times 2 is what I'm using for my 16. So let's see what we've got now. The inside, minus 2 TS. The outside, minus 24 TS. Well, it's closer. Minus 26 TS, but still not there. We might actually have to get a little wilder. Try the 1 and the 16. And, again, I'm thinking to get that 49 back, I erased the wrong thing, just a minute. That 3 is locked in place. To get that 49 back, I'm thinking I need that 16 on the outside to hook up with my 3. Let's try and see. 16 and 1. I'm not going to write the 1 in front of that t. Well, check your outside and inside. Let's see what we've got. The inside, minus TS. The outside, minus 16 times 3. How about that? 48 TS. A total of minus 49 TS. So this is how that factors. If you want to clean it up a little bit so it looks a little prettier, that's fine. But that's how it factors. Now, I have a little issue with your textbook author in this section. Very rarely do I argue with Dr. Lyle, but in this case, I'm going to have to. I want to work problem number 82. And in problem number 82, the interesting thing is we have a negative coefficient on our leading term. That makes things crazy. I don't want to try to factor this with that negative on the front. So, check for greatest common factor. There's no greatest common factor other than 1, but I do want to factor out this negative. I'm going to factor out the negative. If I pull a negative out of negative 5x squared, I get positive 5x squared. If I pull a negative out of positive 2x, I get minus 2x. And likewise, minus 16. Not sure? Distribute that negative back in. It returns you to the previous step. This negative is going to act like my greatest common factor. So in my next step, don't forget your negative. And then I'll say, if this factors, it factors as a pair of binomials, each starting with some x term. In fact, it has to be 5x and 1x, because there's no other way for that 5x squared to fall apart. My signs will be opposite. I'm guessing where they go, but they'll tell me if they're backwards. And then I need some way for that 16 to fall apart. Let me hold right here and explain what I don't like. Look above this homework set that contains number 82, right there above number 79. And just above the instructions, she gives you an example problem. She says above that example, just below number 77, if a trinomial has a negative coefficient for the second degree term, such as, it's usually easier to factor by first factoring out the common factor, -1. I agree with that. But here's what I don't agree with. She actually shows the 1. Look at that second step. Here on the board, it's this step of my problem. She actually shows the 1. I don't think that's appropriate. It's certainly not appropriate in a final answer. When you turn to the back of the book and check these, she's going to have a -1 sitting there. I'm telling you right now. You will not put a -1. You will simply put a negative because the 1 should not be visible. Okay? Make sure you get that straight so that when you're looking these up in the back and you see her -1, don't correct yourself and put the 1 there. I don't want to see that 1. Just the negative. Just that negative. Okay. So what have we done so far? We factored out a negative so that my leading coefficient would be positive as I go to factor. We said if this factors, it will factor as a pair of binomials, each starting with some x term. I even did one better, said it's got to be 5x and x. I said my signs have to be opposite. That's what this tells me. And now we're guessing how that 16 falls apart. Is it a 1 and a 16, a 2 and an 8, a 4 and a 4? That number's kind of small compared to the other two. So I'm going to start with 4 and 4 this time. If I start with 4 and 4, well, my gut led me astray. That's going to be a 4x for my inside, a minus 20x for the outside. A total of 2x. Minus 20. Sorry guys, I knew something wasn't right. 4x in the middle, the outside is minus 20x. A total of -16x in the middle. Sorry about that. So that's not it. Well, of course, swapping the 4's doesn't do any good. It produces the same thing. So let's try the 2 and the 8. Let's try the 2 and the 8. I don't think I want the 8 here to pair up with that 5 on the outside. So let me try the 2 there and the 8. 2 and 8 to give me that 16 back there in the previous step. That 16 is going to fall apart as a 2 and an 8. Now how does this work? That gives me a positive 8x in the middle and a minus 10x on the outside. Even my signs are right because it gives me back that negative 2x there in the middle. Don't forget your negative out here in front. It's got to be part of this answer. Now there's our final answer. Please remember, I don't want to see a -1. I don't want to see that 1 as a factor. Show me just the negative. I do not think it is appropriate to have a -1 as a factor in a final answer. Just show me that negative. All right, guys, when we look at this section again, we're going to look at a different method. So, homework is assigned using this method. Next time I'll give you the same homework and say, try the other method. For now, I want you practicing this unfoiling, this trial and error method.